homework to help with Jen, and we're looking at chapter 4, problem 87. We're going to do A and C in this section. Now, what they want us to do is they've given us two redox equations, and they want us to balance it using the oxidation states and tie lines method. Okay, so the first thing that we need to do is we need to go through and we need to assign oxidation states to our compounds. Okay, so the hydrogens here each have +1. Okay, and there are 6 of them. So that gives us an overall +6 from all the hydrogens. Okay, and the carbons, there are 2 of them, and they need to balance out our +6. So each carbon has a -3 charge. Our oxygen is in its natural elemental state, so it has an oxidation of 0. Okay, CO2 is going to have an oxidation number for the oxygens of -2. There are 2 of them, so the carbon has a +4. And the water will be -2 again, and each hydrogen will be a +1. Okay, so there are oxidation states, and we can see that our elements in some cases are changing. Our hydrogen is not changing, so we won't really need to look at it too much. Okay, so let's take a look at what's happening here. Our carbon is going from -3 electrons to +4 electrons. Wow. Okay, so what this means really is that we are losing 7 electrons. That's absolutely crazy. Okay, loss of electrons is oxidation, so it's oxidized. Okay, and it would be the reducing agent. All right, now let's take a look at our oxygen here. Okay. There's oxygen in 2 places. It goes from 0 to -2, so it's getting more negative, which means that it is gaining 2 electrons. Okay, we don't look at all of them, we just look at 1 each. Okay, so each oxygen is gaining 2 electrons. Okay, now what we need to do is we need to balance these out. Okay, so 2 and 7, the only way to deal with these is to make them both 14. Okay, and by 7 makes that 14. Okay, so what we end up doing then is saying, okay, well, if we need to do this twice, then we need 2 of these. I'm sorry, no, we already have 2 of those. And me without an eraser. No, I have an eraser. Good, sorry. We already have 2 oxygens. So, perfect, because we need 2 carbons. I'm sorry. I misspoke. We already have 2 carbons, and we need 2, so we're good there. Oxygens, though, we need 7 of them. So actually, this might be tricky. And we have 2. So actually, you know what? To make this easy for now, let's say 3.5. Okay, so that's 3.5 oxygens. Okay, so now what we're doing is we have 7 oxygens, and we have 2 carbons. Okay, so let's see if this will balance everything else out too. So we'll need 2 CO2 because we have 2 carbons, and we have 6 hydrogens here, and so we'll need 3 waters, and actually that balances out our 3.5 O2 because here we have 4 oxygens and 3 oxygens, so we're good. Okay, so that is how we do this, by balancing electrons first. So we have 1 C2H6 plus 3.5 O2 gives us 2 CO2 and 3 H2O. You could double all these to make that a 7 if you wanted, but it's not necessary. Okay, now let's look at C. C is already in some ions because what we're doing is we're dealing with aqueous medium. Okay, so somewhere in this bunch there are some negative ions too, maybe chlorides or nitrates or something along those lines, but we haven't included them because they're just spectator ions. So let's take a look at what our oxidation states are here. Here, our cobalt is a +3 oxidation state. The nickel it's in its natural elemental form, so it has an oxidation number of 0. The CO2+, well, the oxygen, oh, I wrote that incorrectly. That's not CO2+, that's cobalt 2+. There we go. Okay, so our cobalt has just changed. So now our cobalt is a +2, and our nickel is a +2 oxidation number 2 because it matches the ion there. Okay, so let's take a look at what's happening. our cobalt, CO3 plus to CO2 minus, okay? This is losing 1 electron, so it's oxidized. Okay, now I'm sorry, going from +3 to +2, boy, I am really misstating things. I'm sorry. We are gaining 1 electron. There we go, because +3 to +2 comes up, or down rather, on the number line. Okay, so back to the nickel now. With nickel, we are going from a 0 to a +2. So here, we are losing 2 electrons. Okay, now, when we look at this, this is one of those cases where there's really nothing here to balance except the electrons, okay? So basically, each nickel loses 2 electrons. Those 2 electrons have to have somewhere to go. It's reduced. Those electrons have to have somewhere to go. So we need 2 cobalts. We need enough cobalts to take them all. So we say -2, that'll give us 2 electrons. So then we have 2 electrons lost, 2 electrons gained. So we need 2 cobalts. And so our answer here is 2 CO3 plus nickel gives us 2 CO2 plus nickel 2 plus. And then at the end we can check ourselves by balancing our charges. Okay, here we have 2 positive here and 4 positive here. So we have 6 positive charges on this side. And so this side also needs 6 positive. We do. We have 2, 3 positive charges. So we have 6 positive charges on each side. So we haven't lost any.